All right, what we've been doing is quantitative, meaning we've been doing pure numbers. We're going to work a little bit more qualitative now. How do we find a force, or how do we know what happens to the force if you don't actually know any of the charges, you don't know the distance, you just know that something got doubled or something got tripled or cut in half. So these examples match on the worksheet that you've got to 1, 3, and 7. Now the first section is what happens when charge changes. Okay, so in this story, it says 2 charged objects have a repulsive force of 0.080 newtons. If the charge of one of the objects is doubled, what is the new force? Here's how we start. Okay, we're going to start by writing down the old one. This is the value that they just gave us. It's the old force. Okay, now this force they determined using the equation Coulomb's constant is equal to the product of the charges divided by r squared. So when they plugged everything into these values, K, Q1, Q2, and R, they ended up with 0.08. All right? So how we're going to find out what this is if it doubles is like this. We're going to say everything that doesn't change, we're just going to write down a 1. Okay? So if it doesn't change, we're going to write down a 1. We're only going to put a number in for the thing that changes. Okay? Do I need to make it bigger? Okay. So in that case, that becomes, does the Coulomb's constant change? No. Coulomb's constant, so we just write a 1. Does charge 1 change? I don't know if it does, but one of them changes. Does it matter if it's Q1 or Q2? No. So we'll just put it in there. There's the charge that changes, and then the other one doesn't, so it's right there. Now the next one is the separation distance. Does it mention the separation distance? That answer is no. So if it doesn't, if they don't mention it, it gets a 1. So what does this become? 2. So to keep this a true statement, what do I have to do to the old force? The exact same thing that happens on the right-hand side. I have to double it. Okay? So by the way, this is the answer to a second question. A second question can be, how does the force change? Put them in. How does the force change? It doubles. Say it doubles or 2 times. Okay? So we take that doubles that we saw right here, and so our new force then is going to be 2 times the old force. We're going to repeat the same steps every time. So if the second question, which is the number 3, is the second section on the worksheet, is what happens if distance changes. Now again, if they don't mention it, you just put a 1 in. So same story, it's a repulsive force of it's a repulsive force of 0.080 newtons. All right, and that was done using this equation. This is the relationships that were used. Coulomb's constant, the product of the charges, divided by the distance squared. Okay, so we're going to see what happens to the old thing. All right, this is our old. What happens to the old when we make a few changes? Does Coulomb's constant change? No. It doesn't say anything about the charges. So if it doesn't say anything, we just put a 1 in. And it does tell us that the distance is doubled. The number for doubled is 2. And what happens to the 2? It becomes squared, which I just realized we didn't do at the top. Okay, so what value is this? 1/4. So if that's 1/4, what has to happen to the other side to make it an equal statement? Multiply it by 1/4. Okay, so the other question on this is, how does the force change? You could say it's quartered. You could say 1/4 times. It's multiplied by a factor of a quarter. So how do we find the new force? Is going to be equal to 1/4 the old force. So it's 1/4 times 0.08, which is going to give us 0.02. And I also just realized that I wrote down the equation, but we didn't do the math up top. So the math would be 2 times 0.08 for the first one. So your new force is 0.16 newtons. So here's our third one. This third one is with everything changes, or rather anything changes. By the way, it says it has a repulsive force. The original force or the old force is repulsive. What does that tell us about the charge on them? How do you know it's negative? How do you know it's positive? What's the rule for repulsive? It just means they're the same. We can't tell if it's positive or negative. We just have to tell that they are the same. Okay, so the old force is 0.08 newtons. And the old force was found using this equivalency. All right, the same one we've been using all along, Coulomb's law. So here's our old. Let's figure out the new. So to do this, it says two charged objects have a repulsive force of 0.080 newtons. We're going to, if the charge of one of them is doubled and the distance is doubled, then what is the new force? Okay, charge of one is doubled and the distance. So the constant never changes. We're going to double one of them. It doesn't say anything about the second charge, so it gets a 1. It tells us that the distance is doubled, and that's what we have. So how does that math work out? 2/4. Just as a verification, why am I squaring the number on the bottom? Because in the equation it's squared. All right, if it wasn't squared in the equation, we wouldn't do anything to it. So this becomes 1/2. This is our new value. So to make this an equal statement, we have to get the 1/2 on the other side. So the old times the 1/2. So then what's new is going to be 1/2 of the old. Okay, so we're going to go ahead and say it is 1/2 times 0.08, giving us 0.04 newtons. That is our new force. And the other question would be, how does the force change? It's halved, cut in half, anything like that. Okay. So they can either ask, with a question like this, they either ask you, how does it change? Or what is the new value? One or the other. And that covers it.